Sri Jayendra Saraswati Vidyalaya Matriculation High Secondary School, Singanallur.
Today we are going to discuss the problems in electronics and communication lesson of class 12 physics. First problem. The given circuit has two ideal diodes connected as shown in the figure below. Calculate the current flowing through the resistance R1. So when you see this circuit diagram, you can understand clearly that D1 is reverse biased and D2 is forward biased. So when a diode is connected in reverse bias, it will not conduct current. So D1 will not conduct current and the current passing through the D1 is equal to 0. Either you can have. So the total resistance is 4 ohm because R1 is equal to 2 ohm, R3 is equal to 2 ohm, both are connected in series. So the effective formula for resistance in series mode is R is equal to R1 plus R3, which is equal to 2 ohm plus 2 ohm, which is equal to 4 ohm. The total voltage is 10 volt. Now we have to find the current through R1, which is equal to I is equal to V by R, our Ohm's law formula. So which is equal to 10 divided by 4. So the answer is 2.5 ampere. The current passing through the resistance R1 is 2.5 ampere. Now the second problem. 4 silicon diodes and a 10 ohm resistor are connected as shown in the figure below. Each diode has a resistance of 1 ohm. Find the current flows through the 10 ohm resistor. So you can see how the 4 diodes are connected. It is like a Wheatstone network. In the center across C and D, one 10 ohm resistor is connected. We have to find the current through the 10 ohm resistor. So from the diagram itself, you can notice that D2 and D3 are forward biased and D1 and D4 are reverse bias. And we know that in reverse bias, the diodes will not conduct the current. So this circuit can be redrawn with the diodes D2 and D3 alone as follows. So we have got the two diodes. D2 and D3, we know the potential drop across the diode. This is a constant value which is 0.7 volt for a silicon diode and whose resistance is 1 ohm. So I have given it separately and you have got a 10 ohm resistor followed by D3. All of them are connected in series. So such a connection is made. All of them are connected across a 3 volt battery. So the total resistance is 10 ohm plus 1 ohm and here for D3 it is 1 ohm. So the total resistance is 12 ohm. The total potential is 3 volt minus voltage drop across D2 and D3 we have to include, which is 0.7 and 0.7 for silicon diodes. So 3 minus 0.7 minus 0.7, which is 1.6 volt. So further the circuit can be reduced to a circuit as follows. You have got a single voltage of 1.6 volt and a resistance of 12 ohm. This is the equivalent circuit for the before circuit. Now we can easily find the current through a 10 ohm resistor. The formula is our Ohm's law. I is equal to V by R. V is 1.6 volt and R is 12 ohm. So 1.6 divided by 12, which is equal to 0.1337 ampere. Now the third problem, assuming VCE value is 0.2 volt and beta value is 50, Find the minimum base current IB required to drive the transistor given in the figure to saturation. So VCC is from the figure you can understand VCC is 3 volt, beta is given as 50. You have to find IB value. We know that the collector current VCC is equal to 3 minus 0.2. That is VCC is equal to 3 is the total voltage minus 0.2 is the VCE, which is 3 minus 0.2 is 2.8 volt. So we can easily find IC value using the formula. IC is equal to VC by RC. VC value now only we found it as 2.8. RC value is given in the diagram as 1 kilo ohm, which is 1 into 10 power 3 ohm. So 2.8 divided by 1 into 10 power 3, which is equal to 2.8 into 10 power minus 3 ampere. So we have found IC value. From this you can find IB value using the beta formula. Beta is equal to IC by IB. Beta value is given in the problem. IC now only we found. So IB, we are reversing this formula. IB is equal to IC divided by beta. Substituting the IC and beta value, you get the IB value as 56 into 10 power minus 6 ampere, which is nothing but 56 microampere. Now the fourth problem, a transistor of alpha 0.99 and VBE as 0.7 volt is connected in the common emitter configuration as shown in the figure. If the transistor is in saturation region, find the value of collector current. So VCC value is given as 12 volt, alpha as 0.99, VBE is equal to 0.7 volt. We are supposed to find the value of IC. For the whole circuit, we are applying the Kirchhoff's voltage law, which is VBE plus IC plus IB into 1K plus 10K IB plus IC plus IB into 1K is equal to 12, because 12 is the total voltage applied. So in this equation, we are going to substitute IB value and IC value. We will find what is IB, IC, and we will substitute in this equation. Simplifying, we will get the value of IC. We know that IB is equal to IC by beta. So first we need to find the beta. So we use the relation between alpha and beta as beta is equal to alpha divided by 1 minus alpha. Alpha value is known. So substituting in this relation, you get beta is equal to 0.99 divided by 1 minus 0.99, which is equal to 0.99. So IB is equal to IC by 99. Similarly, IC is equal to 99 into IB. These values we have to substitute in equation 1. So you know that IC is equal to 99 IB, IB is equal to IC by 99, VBE as 0.7 volt. So substituting all these values in equation 1, you get 0.7 divided by 10 power 3 plus 99 IB plus IB plus 10 IB plus 99 IB plus IB is equal to 12 by 10 power 3. So simplifying this, you get 100 IB plus 10 IB plus 100 IB is equal to 12 minus 0.7 divided by 10 power 3, which is equal to 210 IB is equal to 11.3 divided by 10 power 3. So the IB value is 0.054 into 10 power minus 3 ampere. From this, you can find the IC value using the relation IC is equal to 99 IB, which is equal to 99 into 0.054 into 10 power minus 3 ampere. So IC value is 5.34 into 10 power minus 3 ampere, or it can be written as IC is equal to 5.34 milliampere. Now the fifth problem. In the circuit shown in the figure, the bipolar junction transistor has a current gain beta of 50. For an emitter base voltage VEB is equal to 600 millivolt, calculate the emitter collector voltage VCE in volts. So beta value is given as 50, VEB is given as 600 into 10 power minus 3 volt. Since it is a millivolt, you have to multiply by 10 power minus 3. RB value is given as 60 kilo ohm, RC is 500 kilo ohm. So first we will find the value of BB, which is equal to VE minus VEB. So 3 minus 0.6, which is equal to 2.4 volt. So we will find the IB value using the formula I is equal to V by R, our Ohm's law. So IB is equal to 2.4 divided by 60 into 10 power 3, which is equal to 0.04 into 10 power minus 3 ampere, which is equal to 40 microampere. This is IB value. IC value you can easily found using the relation IC is equal to beta into IB, which is equal to 50 into 40 into 10 power minus 6, which is equal to 2 milliampere. Now we will find VC value using the Ohm's law. VC is equal to IC into RC. Substituting the RC value, which is 500. 500 IC is VC, which is equal to 500 into IC value. We have found it as 2 into 10 power minus 3. So the VC value is 1000 into 10 power minus 3 volt. We have to find VEC. VEC is equal to VE minus VC. That is 3 minus 1, which is equal to 2 volt. So the voltage across VCE is equal to 2 volt.